Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the courtyard of the Pentagon for DoD Lab Day, an extravaganza of technology from each of the military services as well as DoD. And we are starting our coverage here with Dr. Eric Gillman, who is a particle physicist with the Naval Research Lab. It's very rare that you see something in the press kit that you think, wow, this has really incredible applications, and parts of it are extremely, I would imagine, classified. Talk to us about dusty plasma, what it is, why it's important, and how, and the work you guys are doing on it.
Yeah, so plasmas are essentially a group of charged particles. So you have ions and then you have positively charged electrons. And what we study is the interaction of those with microparticles. So the plasma actually charge up these microparticles, and when you charge them up, they can react differently to electric and magnetic fields. So that's the basic physics of what we study. But as you mentioned, there are a lot of applications. So just a few of them are hypersonic vehicles go through this communications blackout. So we are studying different ways that electromagnetic radio signals interact with dusty plasmas. And it's important also the ionosphere around the Earth naturally is a dusty plasma. So communication with satellites, looking at over-the-horizon radar and how these electromagnetic signals interact with that dusty plasma is essentially what the applications of this basic physics that we'd like to translate.
There's also a very terrestrial use of the technology in order to make sure that computer chips, for example, don't get dust that fall on them in the production process.
Exactly. So plasmas are used to process semiconductors, and in the process of doing that, they generate dust particles. So you get these dust particles levitating in a plasma. And when you're done processing your chip, you turn your plasma off, these particles will fall down on the chip that you just processed. And so if these particles fall just right, they can actually cause defects in the semiconductor that you just processed. And so it has applications far-ranging from the cell phone in your pocket to the computer on your desk and tablets, everything in between. And so it's a very important process that really is an important driver for size, limiting the feature size that you can process on these ships.
And orbit degradation as well, right? I mean, you're studying that because it's particles that slow down a satellite.
Right, so this is very important for space situational awareness. Our satellites that are in space, orbital debris exists in the ionosphere as well, and that can affect satellite performance and even cause satellite failure in some cases. So it's very important for the Navy in that aspect as well.
And so what is the kind of research you're doing? Where are you doing it? Do you have enough money to do it? These are all questions that I thought I would ask. Your boss is standing right here. So clearly you get as much money as you need. But talk to us a little bit about the work, the research, what keeps you guys excited, and what are sort of the next big breakthroughs you guys are looking at?
Yeah, so I mean, so we do experimental physics on this. We also supplement it with some theory, and so we do a lot of different aspects of things. Always looking for the next new thing, how we can advance the things we're currently working on, and so we're always like to have that creativity of coming up with new ways to look at different applications and using the dusty plasmas in different ways, as well as getting a greater understanding of the basic physics around the dusty plasmas. So.
And where's most of this work done?
So this work is all done for us at the Naval Research Lab, which is here in DC, just down the road a few minutes. And so we do it in the lab. We work with the Space Experiments Group section, NRL and the Plasma Physics Division. And so yeah, we have a lab with vacuum chambers that we do all kinds of different experiments in.
And what's roughly the amount of funding that, for example, goes into what you guys are doing?
So it varies a little bit, but a lot of it comes from basic NRL base funding. But we also have a few projects with ONR and a few other different federal agencies that fund a lot of the activity that goes on in our lab.
But how much is the monetary amount? Because when I want to sort of put what you guys are doing, here's a real groundbreaking amount of research you're doing. But to show people, in proportion to this vast $600+ billion defense enterprise, how this tiny little piece of it can give you such breakthrough results.
Right. So I started off as an NRC postdoc at NRL and then went into the Carls Fellowship. And now I'm funded under a 6-1 project, and we get about $150K or so a year to fund this particular research. And the amount of time that I can spend on it because of our budget is limited. But really, I mean, it can have such huge effects because everyone uses their cell phone every day and a computer almost every day. And so really improving and minimizing the size of those devices is a big driver, and that's a big area where it can affect everyone over.
So we're making a plug. You need a couple of $1 million a year at least in order to drive this research forward faster.
Yes. So the more money we get, the more time we can spend on it, the more people we can bring in to help us work on it, look at it, run a lot more experiments, and look at it in different ways.
And one of the things you guys are also pride yourselves on is the partnerships you're doing with universities. What are some of the, you went to University of Michigan for your doctorate in nuclear physics, right? Did I get that about right? Talk to us about some of the educational institutions you're working with in order to drive the sort of state-of-the-art of the science ahead.
Yeah, so NRL does a lot of outreach working with undergraduate students, graduate students who are currently in doctoral programs. And then we also do a lot of collaboration with universities. So we still do keep in contact with Ed Thomas, who is at Auburn University and runs the magnetized dusty plasma experiment. I still keep in contact with my advisor at Michigan, who still does some related research. And so we do a lot of collaboration and keep them involved, and proposing collaborations with them on when we look for funding really helps us to look at it from a lot of different aspects and make sure we're getting a whole complete picture of exactly what can be done with this technology and what others are doing currently in the field.
I have to take you now to a serious question, which is about the Big Bang Theory. So because of the Big Bang Theory and movies like particle physics, all of a sudden particle physics, and you're an experimental physicist. Obviously the program has an experimental physicist and an engineer, as well as a particularly lovable theoretical physicist. How do you like the show? What do you like about the show? And where do you think the show gets it totally wrong?
As far as Big Bang Theory, the TV show? Okay.
That's the important question here. Because Bill's already happy with your budget answer, so.
Big Bang Theory is, they stretch it to make it interesting, right? But there are a lot of, quirky people in the field who definitely make things interesting as being an experimentalist. So, experimentalists and theorists always kind of give each other a hard time. So it's, all in fun, though. You can't have one side without the other, so.
Good science and real equations, so at least they've got that going for them.
Yes. Yeah. Yep. So it's a funny TV show. But
what attracted you to get into particle physics?
Really, I had an internship at NASA as an undergrad, and that really got me interested in the space side of things. And then when I came back to Michigan, my advisor used to work at NASA, and so that's how I got connected with him. And then from there, it just grew, and it's a very interesting, visually appealing thing to look at, and so that's what really kind of hooked me. You get to see all these, glowing plasmas and these dust particles that are levitating above, and trying to figure out exactly how it all works and how, that's just how it all ticks is what I really find interesting. So.
Well, that's awesome. Thank you very much for what you do, and look forward to staying in touch as you advance this with a lot more money from DoD.
Yeah, that would be great. Looking forward to it.
Dr. Gillman, thanks very much.
All right, thank you.